issue that we've struggled with now 25, 26 years. It's taken a very long time for us to learn to deal with it, and we're still learning to deal with it. The presenter that I think was first in this series, Barb Bletcher, did an excellent job of covering some of these topics, and specifically how to check for various mites and whatever. So I want to come into it from a slightly different perspective. I had the good fortune, I guess, of being there before there were mites. Now, I'm not 150 years old, but I remember bees and bee yards and bee operations before we had to really worry about what these various mites were going to do. And in this Midwestern apiary here in 1944, that beekeeper standing there with the hive slightly ajar, see if I can get the cursor to work. Of course it didn't. He's the guy standing here in the corner with the lid cracked slightly. He never had to worry about getting mite treatments in. Indeed, one of the interesting things about this is that there isn't even any plastic in that operation there in 1944. So all of you people who've started beekeeping in the last 5 years or less, you've come into a radically changed beekeeping world. We've gone from wood and wax and traditional to plastic, lightweight, electronic, and parasitic mites everywhere. Those of us who were there before live in perpetual shock that this world no longer exists. And so people such as I'm like a World War II veteran. Every year there's fewer of us, and we're moving on. And every year there's more and more than you people who never knew bees before mites. So a lot of things that we do today, a lot of the attitude that our beekeeping industry in the U.S. has today is because of the carryover that we did from moving from this other world to this world that we're in now. Our introduction was with tracheal mites. Folks, when we did this, I did it on a Mac, and then when I transferred it over, some of the formatting went squirrely on me, and so we decided to go ahead and use it with the squirrely formatting because it's still readable without trying to go back and change this and then just get different issues. So I apologize for some of the spacing and the designations there on that. Tracheal mites was our first exposure to what to do with these things. They're an old pest. They're reasonably well adapted to honeybees. We knew that tracheal mites, our forefathers and mothers knew that tracheal mites were something that we really didn't want to get involved with as far back as 1904. And from about 1904, 1920, it took that long to figure out that it was a mite, M-I-T-E, that was doing this, and it was identified in 1921. It lives in the breathing tubes of the trachea. It causes mechanical obstruction of the bees trying to draw a good clear breath. They imbibe or drink blood, so the bee is weakened and run down in that regard. And at the same time, these mites are no doubt vectoring some kind of secondary viral invader, as all mites seem to do at one time or another. So it was recognized early on that this was not something that we wanted here in the U.S. So in 1922, the U.S. restricted all imports of honeybees, and later that was even modified to restrict even semen importation from drones in order to keep out any of this exotic material, pest that were somewhere else in the world. And that really held up for a long time. About 64 years or so, 62 years before the mites finally came in through Texas. We think that probably during the Africanized bee years, when Africanized bees were being moved from Africa to South America, that the mites probably got transferred during that time. We know they were in Mexico in the early 80s. And as became a later pattern, We spent a good deal of time in Mexico looking, studying, trying to understand, and preparing. And then boom, they were found in Texas. And you know, here on my graph, it just says Texas, 1984. I need to go back to that second slide that I showed. You had to be there in 1984. That was our industry's first exposure to an exotic new pest like this. We had heard about these things forever, and then suddenly they're in Texas. And so the Animal Plant Health Inspection Service did surveys, found these things, tried to kill bees. I think around 25,000 colonies were actually depopulated, as it's called, to try to control this before it was realized that they're basically everywhere. When these mites came in, they were devastating. They were a lot like Varroa, being devastating. And they basically killed half the bees in the U.S. at that time. And now they've kind of calmed a bit, and that's possibly due to Varroa control procedures also having some effect on controlling tracheal mites. You're going to need a dissecting microscope with about a 50x magnification to see these things, and you're going to have to undergo a tedious procedure of dissecting the bee and dissecting out a tracheal tube. It can all be done. There's some YouTube segments that show how to do it. It's not difficult to find it on the web, on the techniques for working your way through this, but it's very difficult and tedious to do it, and you can't apologize to the bee. So if you take the bee apart, pull the head off, take that respiratory system apart, and nothing's there, you're kind of apologetic to the bee, but you can't go back and put her back together again. The female mite invades a new bee when that bee is about 1 to 3 days old. The mite feeds, and she lays about 1 egg per day. And in that second graph chart there, where it says 3 days, you can see 1, 2, 3, 4, 5 objects. 2 of those are adults, and 3 of those diagrammatic images are eggs. I find it to be very interesting that the egg is very nearly as large as the adult that produced it. So the mite feeds and lays about 1 of these eggs per day. They begin to jam the tube up. The larvae hatch. They feed on bee blood. As that's shown in the diagram, the adult females hatch in 14 days and the males in 12. And then the daughter mites exit the old bee and they quest. These mites have 8 legs, and they'll probably use about 2 of them to hold on to a bee hair, follicle, particle. And then as they brush up against another bee, they'll use the other 6 legs to grab on to the next bee that's passing by. And in this way, they'll jump from bee to bee to bee until they find a new young host, and then they'll enter the trachea, and they'll start this process all over again. You know, there's not much concern now. And there are those who think that maybe we became relaxed too soon. But when Varroa came in, Varroa just obliterated everything. They made tracheal mites look tame. For lack of a better word, they overshadowed tracheal mites. Tracheal mites were hard to see in their heyday, which was short, only about 3 years. We were very superstitious. Anything that didn't go right with the colony, we probably had tracheal mites. We basically jumped around trying to figure out what was going on. But very possibly Varroa made these mites look too routine. We did develop, we being the scientific community, some techniques for controlling tracheal mites. And in this old grainy picture I snapped here about 25 years ago, you can poetically see an apistan strip for controlling Varroa, and up in the right-hand corner you can see that white glob, which was a shortening patty or a Crisco patty. It was discovered that this light oil film that bees would pick up seemed to have some effect on confusing or disrupting the mite's ability to transfer from bee to bee to bee. It could have been nothing more than making the bee slippery, and the tracheal mite had trouble grasping the bee, or what? I don't know. I found some literature that said that grease patty may actually have some effect on the electric potential that bees carried, and mites were disrupted in that way. I've given you a couple of these formulations there for mixing this stuff up if you should choose to do that. But increasingly, over time, tracheal mites are out of sight, out of mind, and I don't know if that's exactly what should be done. And now, the main act that needs no introduction, Varroa destructor. To this point, this is simply the biggest thing that's ever happened to beekeeping. And I worded that this way because I took this quote directly from a prominent USDA scientist who worded it this way about Africanized bees. That to this point, Africanized bees were simply the biggest thing that's ever happened to beekeeping. And I realized that as big and as serious and as disrupting as Varroa has been, that there's still stuff out there that we don't want. Varroa, Tropicolaps chlarea, other mites. We don't have everything bad in the bee world. So I've qualified this, that up to this point, this is the biggest thing that's ever happened to beekeeping. It was a major event, a life-altering for all of us. At first, you had to have been there. In 1987, we just got beaten up by tracheal mites. We basically lost that battle. We'd killed tens and tens and tens and tens of thousands of colonies because of tracheal mites. And now we had to deal with Varroa. And it was just a remarkably confusing, disoriented time. The effects from Varroa were reported to be different in different countries, in different areas. Some people, you could hear whatever you wanted to hear. Some people would say that Varroa was not that big of a deal in Africa. People in South America were being beekeepers, and their bees were being destroyed by Varroa. So it was just all over the page. And it's important that you also remember in 1987, the web, if it existed at all, was in its absolute infancy. And so we depended on the beekeeping magazines, you depended on going to meetings and hearing talks, word of mouth, extension transfers on fact sheets. There was none of this high speed, it happened today, so you know it right away kind of thing. It was a confusing time. And it took quite a while to figure out that the variation that we had, the species Jacobsoni that we thought we had, was in fact not correct. That is a more milder responding Varroa mite that's in other parts of the world, compared to Varroa destructor, which we now know we have here in the U.S. and in other parts of South America. So we didn't draw the best hand on this. At that time, there were no specific control procedures available. I remember going to a meeting at the American Beekeeping Federation in I think Colorado. And there was a commercial beekeeper there who just went down to the front of the group. There was 800-900 of us there. And he just shamelessly cried before the group because he had lost, I think it was something like 4,000 colonies of bees had died or were essentially ineffective in just about a 6 to 9 month period. And that operation had been begun by his grandfather, developed by his father, and then totally obliterated on his watch. And he had come that day not to seek information about what to do, how to do it. He had come that day to tell us all goodbye, that he would not be able to get back in beekeeping commercially, that no banker in their right mind would loan him the several million it would take to restart. There was no good control procedures for them, and he had just stopped by to say bye. I want to paint myself into a dark corner and then see if I can get out of that corner here in a bit. It was a bleak time. It was a very bleak time to be in beekeeping. because we really didn't know what was going on. We couldn't tell if it was tracheal mites. Varroa mites were killing everything that tracheal mites hadn't killed. Eric Musson in California said that tracheal mites came in and killed half the bees in the U.S. within 3 years. And then in 1987, or hardly 4 years later, Varroa came in and killed half of the remaining half. About all we could do was develop a map that showed these new finds as they occurred. So the main thing we did was we just watched for the map to come out to see if a particular state that I lived in at the time, then or now, or that you lived in, had Varroa turn up in that particular state. It's also important that you realize that if you think it could not get any worse, oh, it can get a lot worse. Because what had happened was that over the confusion of what Varroa was doing, assisted by tracheal, we had this Africanized bee issue going on. And the public was absolutely terrified of this Africanized bee thing. I mean, they just were titillated by the concept of, a swarm of bees with bloodshot eyes and crossed ammunition belts and carrying scimitars by their side, storming out of the sky, attacking an innocent guy on his lawnmower one Saturday afternoon. So movies were made, fact sheets were handed out, and horribly, a few people did die. Now, it's that kind of statistic that you use when you're describing lightning strikes or whatever. But when those people were horrifically killed from bee stings, of course, it made national news. And so we had to deal with this Africanized bee thing. At the same time, we were dealing with massive die-offs from Varroa. All started with the confusion caused by tracheal mites. It was a really raucous time to try to struggle along through this whole thing. I want to stop for a second before I go to this next picture and tell you that I was in the University bee yard. Denise, it's where it is right now, across the bridge here in Worcester, Ohio, for those of you who know this area. And I was in that apiary doing just routine work, having a look at routine bees, and I was surprised to see one of the worker bees was marked on its thorax with a dark, rusty-colored red mark. And I knew I wasn't doing any work that required marking bees, and even if I did do work that required marking bees, I would have used a primary color. Yellow, white, green, red. I wouldn't have used this odd dark color. So I was taken aback. Maybe one of my students did it. And as I had a closer look, I was almost shocked to see the mark abruptly run away. And it ran on the ventral surface of the bee. And so you sit there just for a second in absolute disbelief that the mark on the bee moved. And then you realize, oh my stars, that was Varroa in Ohio State's bees. And that was the first time I had seen a live Varroa on university bees. And as well as I could, I realized at the time that my life with the bees would never be the same. Now, I need to tell you straight away that I didn't realize at that time that 25 years later, 26 years later, that I would still be working on understanding that change. So that was my personal experience on the first time that I saw those bees and the bees that I was responsible for. It was so chaotic that the Animal Plant Health Inspection Service of the USDA approved a limited use emergency permit, Section 18, to use plywood strips soaked in Maverick or Spur for no other reason than for the detection of Varroa. So in this strange time I'm describing to you, we were all running around cutting up quarter-inch plywood sheets into these small strips about 2 inches, an inch and a half wide, 6 inches long, and dipping them in these off-use insecticides on this emergency use permit just to try to find Varroa. We didn't know where it was in the U.S. Just about 3 months later, a separate Section 18 was issued to use this design as a treatment. So we were all running around, running table saws, cutting up plywood, getting this stuff, dipping, using monofilament line to hang these strips inside the beehive, and then just 4 months later, this was all replaced by Apistan, a product that is still available today, and that whole concept of cutting up plywood and doing all that kind of thing was withdrawn. Now, I've asked you to sit through all this because that was the dawn of our chemical frenzy to find a control agent for Varroa destructor. That was our very first effort at thinking we had to do something, or this was going to be the end of us as we knew it. And I know a lot of you now are thinking, I don't want to put any chemicals in my hive. I don't want to use chemicals. I'm going to keep my bees strong and healthy. There's no reason to pollute, and I love you for that. I agree with that. But at this time, in 1987, you would have lost most, if not all, of your bees at that time. It was not an easy time to not try to use something. So that was how we started, and then this is where we are today. I want to say very clearly that I've given you this technique only as a historical reference, and now it's off-label and illegal. And indeed, if you want to use a chemical treatment, we have far better control materials now that are better suited for use in the beehive. So please don't go back and resurrect this stuff. This was under desperate emergency situations, and we were only in this process for about a few months before we cleared it up. The female mite inside the hive on a bee running around is attracted by brood pheromones to a larvae about 8 days old, invade that cell just before it's capped. And it's important that you notice there under this section where I've got at 8 days old, the brood comes first. They invade drone brood first. They preferentially go for drone brood. I'm going to have a lot more to say about that later. At 10 days, the mite foundress hides in the bee brood food until the cell is capped over. That's important, until the cell is capped over, because what are you going to do? This mite is now sequestered inside the cell, and anything you spray, stick, dab, or do whatever is going to be protected and hidden by the cell that's capped over. So the larvae begins to spin its cocoon. The foundress mite feeds on blood and begins to lay eggs. It'll lay 3 to 5 in a worker cell, could go up to 6 in drone cells. And this feeding causes mechanical damage, takes away blood, weakens the bee, and just generally causes structural problems, and the bees end up emerging small and weakened. Now, in the worst case scenario, they vector viruses, and the bee ends up coming out dead or severely deformed. The daughter mite exits, and the mites disperse to new nurse bees, and the whole process starts over again. The male mite normally dies inside the cell. So the big thing I want you to know here, they prefer drones, and the other big thing I want you to know is that these mites are protected by cappings that make it very difficult for us to use any kind of material that gets to these bees straight away. The biggest thing these mites do is they vector RNA type viruses. This mechanical damage is bad enough, but the viruses reduce lifespan, they reduce learning ability. This is the real thing. This is probably what had a lot to do with CCD. It's probably a lot of what causes our bees to be weak right now. About 18 of these viruses have been described, and in one of the previous episodes, Barb Letcher did a great job of listing that better. To me, you just see this kind of thing like I've got in this picture here, these deformed wings, and you know right away that this is a mite vectored viral issue. Now, in the earliest days, we all thought that this was a direct result of the mites feeding on the bees, these deformed wings. But now we know that this is caused by a virus. One of the new things that's on the horizon that everybody has a lot of hope in, Reed Johnson, I think the second speaker, has some experience using this, is RNAi silencing technology. Some of these RNA viruses can be interrupted with this silencing procedure. It's a natural defense mechanism that has no harmful effects on bees, and of course the company would say it's safe and natural, but I think it probably is. It's biodegradable. It's a perfectly common cellular process, and I can't go into any detail much more than this because this technology came along long after my educational process was over in this. So I hope that the new people now, the young people that are working in it, the scientists are able to do something with it. Jerry Hayes, a long time ago, a student at Ohio State with me, subsequently with the Data and Company, then for many years at Florida, has now gone with Biologics to be their bee representative. And so I hope that this company is able to do something that will end up being productive. The company was bought by Monsanto, and that's controversy I'm not prepared to get into, but nonetheless, there's a lot of interest right now in this being something that can give a new control technique for Varroa. You got to watch for the symptoms: deformed wings, crawling bees, pupae at the front of the hive. Of course, you'll see mites on workers occasionally. But the problem with this short list is that crawling bees and pupae at the front of the hive can be caused by really any number of things. So on the list that you would put, if you saw crawling bees and pupae at the front of the hive, possibility of Varroa predation. You could also wonder if this was a tracheal mite issue or pesticides. So it's not always easy to declare that the Varroa is the problem of a list of problems. It's not uncommon to have multiple things go on. Again, Barb Blecher did an excellent job of specifically showing how these techniques worked, so I will review them quickly to keep in the scope of things. But the ether roll was the one that we used first to take about 300 bees. It's about a third of a cup of bees, and to put them in a closed jar. This is a picture here on the right is for sugar shake, not for the ether roll. Put them in an enclosed jar and give them a good jolt with starting fluid, ether. Of course, it kills the bees, and as they die, they regurgitate the contents of their crop. That makes them sticky. You roll the jar, roll the jar, roll the jar over and over and over, and the mites begin to stick to the side of the jar. Ether is highly flammable. You got a smoker going someplace nearby. Good remote chance you might blow yourself up. So you can use soapy water or alcohol if you wanted to be a little bit safer. The sugar shake is about the same procedure, and it's just confectioner's sugar that you shake on the bees, and it causes the mites to dislodge, roll, 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 do the same thing. And then anytime you're looking at brood, it's just common sense. Anytime you got a frame out and you're looking at brood, have a closer look. Watch for American foul brood, watch for sac, watch for good queens, bad queens, and also be watching for twisted wings and whatever. The sticky board came along early in our career too. We made them at first, and then you could readily buy them, and now I think we're kind of back to making them again. A piece of heavy card stock, roughly cut to the inside dimensions of the bottom board, coat it in something like Vaseline or grease, anything that's sticky, fly paper, and then put a piece of 8 mesh screening over that, because if you don't want the bees trying to get down and house clean and themselves getting stuck in the sticky board there. So put a piece of 8 mesh hardware cloth over it, and you can have a look. You can see here on the right this picture I've got. Barb Allshaw had pictures of this. I always look at debris examination. So when you're looking at the front of the colony, when you're looking on the cover that you've just taken out of the bottom board, the metal sheet that you pulled out, I always check that, and just always looking and seeing how many mites you can see there. A lot of mites, few mites, some mites, no mites. Doesn't really tell you much other than the fact that you've got a few mites or a lot. So the screen bottom board is helpful in that regard, but you got to kind of keep up with what's going on inside the hive. The thresholds, and I put here in the Midwest because academically these threshold numbers would vary, but I really bet you that across the country they're going to be pretty similar. In an average size colony, 35, 40,000, you would treat when the mites are at 3,000 to 4,000 mites inside the colony. That would be about 50 to 40 mites per ether roll or sugar roll, whatever, or about 50 plus mites on a sticky sheet on a 24-hour drop with no treatment. Now that no treatment is tacked in there because in the earliest days we did put these sticky sheets down, and then we would add some of these new control products to see how many mites were knocked off or whatever. I was at a meeting last night, and I was talking to beekeepers about this, and there's a realism that needs to be considered, and that is this is a time-consuming process, and it's just one more thing to do. And I think that more and more what's going to happen is that in a group, last night there were about 60 people there, and in that group there were about 7 or 8 people that are really keen on this, are really on top of things, and they were doing this kind of inspection work, and then they were telling the people around them that this is what they found. And then the people around them were discussing what to use, what to put on, and I watched this happen, and I was already thinking this might be a real world way for this to go, is that we don't all do these absolute monitoring processes all the time, but rather we stay in touch with a group of people who are doing them so that we know in general what's happening in our area. So in a perfect world, we would all do it. In a real world, I bet you it's going to be a few dedicated people that do it and tell the rest of us what's happening, and then we'll make our treatment plans from that point on. I'm going to go here in just a bit to the list of current chemical controls, and I got those controls from these various sources. You can refer to this after this presentation is stored. So I wanted to present my citations on where I generated these from. Before I go to that, though, I want you to know you need to respect pesticides. We are not, as an industry, very good at using pesticides inside our hives. We're new to this. We've only been doing it now about 30 years. So regardless of a synthetic or organic insecticide, you need to respect these things. I want you to read and follow labels exactly. And that's going to be difficult to do because this whole process is very inexact. So you treat when you've got, 20 to 50 mites. Well, what do you do if you've got 19 mites? So you read and follow the label instructions exactly, and that means as best you can. Use only registered and tested material. In our earliest years, there was so much going on, and this was such a hectic process, we really developed a lot of backyard beekeepers who were chemists, who tried to be chemists, and probably shouldn't have done that. And dispose of this stuff properly. I've seen old strips and equipment that's put away for winter storage. I've seen strips and the grass around the hives. That ain't right. That's wrong. Put that stuff back in the original pack, put it in plastic bags, and dispose of it in proper landfills and that kind of thing. Here they are. After all these years, this is a list of somewhat sanctioned chemicals that are used in some areas. You need to check with your specific state. If we're talking to people outside the U.S., you may have access to different chemicals than we. It's all over the page. So if you really want to go low-key, lightweight, drop down to the bottom, oxalic acid, lactic acid, and go with some of the softest chemicals that there are there. Sucroside certainly would work well. And then you kind of work your way up the list. If you want to go kind of mid-weight, Apalife, Var, Apagard, something along that line. And then if you want to roll out the biggest guns that we've got, it'd still be Apistan and Coumaphos. These are showing some resistance issues, but they still continue to be the most heavy-duty compound that we've got. So I put this out here only to tell you that there must be 160, maybe as many as 200 chemicals that have shown some kind of efficacy against Varroa. And Varroa has taken everything that we've thrown their way and has still come back for more. So they have been a very admirable foe. As this works out, and as I show you this list, you're going to have to decide what your time frame is, what your personality is, what your interests are, and select a chemical that fits your need, if you decide, in fact, to select chemicals at all. Chemical resistance has already begun to show up several years ago in all the major heavy chemicals. It's a common procedure in humans. When I was a kid, I just despised going to the pediatrician my mom used, because every time I darkened that man's door, I was going to get a shot of penicillin. I mean, for anything. You'd get a shot of penicillin, even you were healthy, just to keep you healthy. And over time, penicillin became completely ineffective. I mean, we all know the story. So basically, we expect chemical resistance to develop, and in fact, we've already seen this now in our mite control products. So if you're going to use chemicals, select at least 2. 3 would be better, rotate their use. Now, you say it took me about 10-15 seconds to say that. It's going to take you a week or 2 to figure out which 2 chemicals, which 3 chemicals, get the data sheets, when you're going to put them on, super's going to be on, super's not on. So this is not a small thing to suggest that you do. But you would really do a better job of controlling mites inside your colony if you had a couple of chemicals that you used and you used them in alternate forms rather than just sticking with one over and over again. As you sense, as others sense, as the inclination grows that a particular class of these pesticides are not working, please do not increase beyond label instructions, because you run a real risk of making the bees far more sick than you ever intended, and in a bad day, even killing the bees with increased levels. So follow the label instructions, as I said before, even as these products begin to wane, and let people under analytical conditions decide if more can be added or if these products are going to be essentially ineffective. Also, if you keep adding, the wax and honey contamination becomes an issue, and you could actually make resistance develop faster. Boy, we really picked out the drones. They take it all the time. Varroa prefers drones. Varrosis means there's fewer flights, shorter duration, reduced sperm counts, reduced fertility, and that means that the queens are replaced more. So one of the points I'd like to leave you with is sometimes it's not always a bad queen. Sometimes it was ineffective drones that tried to copulate with the queen, resulting in her not being a successful queen back in the hive. And so the drones take a real beating in this, because apparently with the longer life cycle that they have, they are preferentially selected by Varroa. They're about 10 times more attractive than worker brood. In a natural nest, about 17% of that natural nest is going to be drone. Now that's a lot of drones for a managed hive. So we try to cut it back to around 5%. In the early days, we tried to cut it back to 0, and that just drove the bees crazy. So at about 5% of a drone population of the cells being drone inside a colony, 50 to 60 of those drone cells would produce the number of mites that 1,000 worker cells would produce. So the point I'm hammering home is that drones are really selected preferentially. So our conundrum is how are you going to raise queens? You got to have 25, 30, maybe as many as 35 drones for queens to successfully mate, and here we are killing them right and left with this Varroa thing. So all I can tell you is if you're raising queens, you really can't beat up on the drones as a method for Varroa control. If you're not raising queens and you think this is a good way to go, then you can beat up on drones to help keep populations down. You can actually get drone foundation. It's green. I think that was a great idea. You can sell that the cell size are larger compared to the workers' foundation, and you can actually do a type of trap cropping inside, where you put one of these, no more than 2 per deep, and then the drones grow. You can see this here, it's like 22 cartridges stacked up and nice full frames of drone. And just underneath there, you can see that there's a spot of green paint on that top bar. So it's always a good idea to mark these frames, because if you're not going to be taking these frames out and destroying these drones, then you're doing nothing more than raising more mites inside the colony. This device is an electrically heated frame that the concept's been around for a while, and now it's available for use. You put this drone comb in, and then as the bees build it up, you can see in the picture here that it's a nice full frame. Then you hook up the pigtail electrical connection to a 12-volt battery, and it destroys all that drone brood, and along with it, all those hundreds and hundreds and hundreds of mites. So you lure the mites to those drones, and then you kill them both. And then the bees go in, clean all this up. They'll eat that drone pulp as much as they can and recycle that. And consequently, the drone population is knocked down. So this is not an invasive procedure. The pigtail hangs out, and it's easy to walk up to. The electric gadget is timed, and so you just hit the button with the 12-volt battery attached to it, and it tells you when it's done. You got to buy them. It's going to be about $100 for the control unit and for a frame, and it'll be about, I think, about $45 to $50 per frame from then on. So this is not going to be practical for anybody commercial or for any great number of colonies. But if this process works, it would really be nice just to go out about every 21 to 25 days, plug in your beehive, cook the drones off, never take the top off, and be gone. It does require some minor modification. Now, I hope this concept works. It's simple, straightforward, could be useful to hobby beekeepers, but it's not something that I'm endorsing, pushing. I'm getting no money from it. I'm offering it to you as a possibility. There's other things along this line. The Oliver trap is the same symptom, except in this case you take it out and just destroy the drone cells there. So you lure the drones to those areas and then destroy them. So some take-home recommendations and suggestions. If you got spotty brood, twisted wings, declining population, and it's August, too late for that colony. Don't even try. Combine it or make other decisions, but you can't treat it. Some have said that keeping the colony somewhat crowded will help with grooming and mite fall. If the bees are all bunched together, they'll unintentionally knock more mites off. You need to know that all mites need not be killed for the treatment to be effective, only about 50%. Certainly virus infections are causing more damage than just mechanical feeding. And Varroa causes a lot of these problems, but not all of them. So as a beekeeper, don't just fixate on Varroa. Fixate on the big picture of modern beehive management. We got queen quality issues that are probably indirectly caused by Varroa. We got nutritional issues that are probably caused by monocropping and herbicidal sprays. No other bee disease has gone away, so we got to deal with that. Certainly pesticides and all the news and the issues with that. And sometimes we just screw up. Requeening, we screw up making splits and divides. We screw up moving bees from one location to another. So sometimes we, the beekeepers, are the issue. I really apologize for the spacing. I had this looking good, but you can still see what I'm talking about. It's an important point to say that many beekeepers are doing absolutely nothing. They do the best they can to maintain colonies that are healthy and populous. Now that's nonsensical, because I know that none of you out there are keeping bees in anything but a healthy and populous way. So it's got to be listed. There it is. People who are doing nothing requeen frequently because these queens don't mate well, they don't last as long. So a nice productive queen seems to help things moving along. Screen bottom boards help some. I'm not sure they help a lot by themselves as a control technique. They're a dismal failure. So no harm done in using them, but don't depend on it. So regardless, if you're doing nothing, you're going to have a percentage of these going to fail. Just have to expect it. This is a very desirable, but a very uncertain procedure. But a lot of you are doing it, and you are keeping bees that way, and you are surviving. So chemically, what to do? Restricting drone brood is not chemical, but certainly it helps the chemicals work if you do restrict drone brood. And select something that is suitable for your personality and for your philosophy. I would like to think you can use the softer chemicals first if you're using chemicals, for instance, Apolife Var or HopGuard. And I don't mean for that to be an endorsement, I mean for that to be a type. And then occasionally, if this is not working, you see it building up, one colony didn't look good, you kind of sense things are going wrong, you may try this heavy stuff again. But check your bees, decide what to use the softest chemicals you can first, check them again, see if the treatment's working, and then make your decision from that point. I want to ask you, what do you feel? You're going to feel uncertain. As I've given this talk, I felt uncertain. You're going to feel somewhat uninformed. Somebody sitting beside you at a meeting is going to know more than you do. You're going to feel overloaded. You got to requeen. You got to put supers on. You got to get those queen excluders off. You got to go out and do that mite treatment. So it's going to feel like a lot to do. You're going to feel responsible because you convinced your spouse this was a good thing to do, and now you're out here trying to keep these mites and bees in a workable relationship. And then after you've done everything you know how to do, you're going to be resigned to the fact that you're still going to see mites. We just have no technique that really does a rock-solid procedure of keeping all the mites under control all the time. It's just as normal, I guess. Normal may not be the best word there, but it's common. These feelings are common. All you can do is stay informed, search around, find something that works for you and for your philosophy, and realize that this probably won't work indefinitely. So always be shopping around for something else that will work for you for a while. And then I hope in the long run that we will get better treatments worked out with maybe this RNAi stuff. Keep this Varroa control concept in line with all your other beehive responsibilities, because I don't want this talk to sound like that all you're going to do day in and day out is go out and fret over Varroa. You're probably going to fret, but go out and enjoy the bees. Today's a really nice summer day. The bees are just flying in swarms. And so beekeeping is still very enjoyable. Don't let this Varroa concept overshadow the pleasure and the enjoyment and the contribution that your beekeeping effort makes to our society. So Varroa control is important, but it's not everything. Keep everything in line as best that you can. Those are my comments. I tried to finish a few minutes early to see if there's a question that I can answer. I am like you. I struggle to keep up, to stay informed, to read, and if it's something that I can address, I will try to get back to you on it. For all of you logged in everywhere, thanks for letting me go through this with you. I hope it helped some. Denise, if you're there, I'll hand it back to you.
Okay, great. Thanks, Jim. We've had several questions about HopGuard, so could you start there? There are some questions about the frequency of application and also how well it's working.
I would have to tell you to read the label instructions. HopGuard is the latest material, so it gets the most interest. It is a variation of the hop plant. I know that Barb Letcher mentioned it last, first episode, I guess. So it's going to give you about the same control. It's not going to just, be head and shoulders better than the other products. It's going to be one of those products that you've elected to use. So it's the latest thing, but it's not the end of our mite control issues. So it's fine to incorporate that in one of the soft chemical uses. I've only used it a couple of times. Others have used it that I've talked with. Seems fine. Now, some of you in some states are going to find out that you don't have a Section 18 to use it. Maybe it's not approved everywhere. So check to be sure you can get it. If you can't get it, please know other things are working probably as well. But this is one of those things that mixes things up and gives us some variation.
Okay, Jim, Joanne is asking if rotating controls, hasn't recent research found that miticides interact with each other in a detrimental way?
That research is still developing, and it does show that initially. And it may very well be that in the future we'll know better which chemicals are synergistic. Dr. Johnson at Ohio State has done work on that already, and I think you said Joanne. Joanne's exactly right. In some cases, this is the wrong thing to do. But at this point, we don't know exactly which ones are wrong and which ones are right, and so we will be stuck doing the best we can with what we know right now. It may change in the future.
Okay, Frank asked if it's okay to alternate Apistan and Checkmite in the same year. He's heard otherwise.
I have heard otherwise too. Those are heavy-duty compounds, and I wouldn't do that. Those Checkmites and Coumaphos, and fluvalinate, those need to be your big guns. That we've already got resistance problems developing. We know we got accumulation in the wax products. So use those as limited as you can. And even though I was not going to make a lot of recommendations today, I will suggest that you stick with one of those per season if you choose to use that. But if at all possible, use the safer stuff. Dispose of those chemicals properly. Don't toss those things, those packs in the cab of your hot truck, and then get in the truck and breathe up the vapors that are in there. Treat these chemicals with respect. But rambling around, I don't think I'd do that. Those are the biggest, strongest chemicals that we have, and I would try to intersperse those with the lesser, softer chemicals if I use them at all.
Okay, Susan asks how you feel about creating nuke splits to interrupt the brood cycle.
Say it again, please.
How you feel about creating nuke splits to interrupt the brood cycle?
Am I interrupting the brood cycle due to disrupt the Varroa mite cycle?
Yes, can you use splits to interrupt that cycle?
Yeah. Yes, you can. You can anything that breaks up the cycle. I think that the questioner probably knew that and wanted that point made because that's a very mechanical, managerial thing that can be done. So making a split, even if you don't want the split to stay a split, you can take it out, break up the cycle, push the mites back, and then a month or two later, put the split back on top and recombine it, and so you've still got the same beehive. Of course, you've got the queen issues to deal with. A few people just simply take a queen out and requeen. So if you want to pick your season of the year to coincide with the requeening process, you can requeen and still cause that brood cycle break that reduces both drone and capped brood that the mites need. So yes, that's one thing that would help, but like everything I've discussed this morning, it can't be the only thing you do.
Okay, Ann had a question about the best timing to do that brood interruption. I'm not sure if maybe Ann's question was answered in what you just described.
If you, I tried to tell the group this morning to look at the big picture and not fixate on this. I don't know that I would be comfortable saying go out and do this only to harass Varroa. I would rather suggest that Ann do it in a normal managerial way to make colony increase, and you do that logically in the spring of the year. Not early spring. Spring's clearly here, good to go. Spring blossoms, maybe another killing frost or two. Make your splits then so they can build up and that colony can be successful in passing the upcoming winter. To say to go out and do it strictly for Varroa control, I don't know if you're going to break up the Varroa cycle that much, enough to say do that. I would like you to make the splits in the mid-spring, late spring, so that the colony has a chance to develop into a winterable colony. And in doing so, a secondary advantage to that was that you also disrupted the Varroa cycle back in the parent colony.
Jim, there are a few questions on the powdered sugar treatment.
Powdered sugar as a treatment is okay, but it's low down the list. It's easy to do. The bees love eating the sugar. You probably knock off some mites, but that too should not be your primary method of Varroa control. The powdered sugar shake and dusting is primarily done as a tool to determine the mite population that you've got. We had hoped early on, when Marianne Ellis at Nebraska worked this out, that this was going to be a really easy, simple solution. But it's better as a diagnostic tool than it is as a treatment tool. But the bees like it. There's no harm done, so if you want to sprinkle sugar on, go ahead and do it. But at the same time, you need to know that you're probably going to have something in your shirt pocket to back that up later in the year. And later in the year is springtime or mid-August or so for most of the U.S. Anything much later than mid-August, the bees do not have enough time to recover, get healthy, build brood, and respond to the upcoming winter months.
James asks if it's possible to develop a drone smell trap to kill mites.
I don't know. It'd be possible. It doesn't exist. I hope he has the technology to do it. It'd be great if you can develop some kind of lure that would lure bees based on drones' pheromones to this particular baited trap. I don't know that that's being worked on, but certainly pheromone attraction is known, and no doubt somebody's looking at it somewhere. But it would not be beyond the Star Wars realm that some kind of pheromone-baited, drone-scented trap could be put in that would lure the bees, that would lure the mites to that. I like that, but it doesn't exist.
Thanks. Finally, Carolyn echoes probably a lot of thoughts out there. She says, thanks, Dr. Tu. I just wish my bees had attended this webinar. So I want to thank you, Jim, for a great session. Thank you to all of our participants.